Section 4.7. We're going to look at isosceles and equilateral triangles. We actually encountered a little bit of this yesterday, but we're going to just describe isosceles and equilateral triangles and some of the theorems that go with them. So we're going to use theorems and corollaries of isosceles and equilateral triangles to find an unknown side or length. So here are some of the parts. This is sort of the anatomy of an isosceles triangle. So what you have is you have legs of isosceles triangles, and the legs of an isosceles triangle are the two congruent sides. We call those the legs. And we call the base the non-congruent side right here. So the base is the non-congruent side of an isosceles triangle, and it's always across from what we call is the vertex angle. So this vertex angle right here is the angle formed by the legs. So it's important to understand which angle is the vertex, which are the legs, which is the base. The base angles are the two angles that are adjacent to the base, and they are directly across from each leg. So those are sort of the pieces of an isosceles triangle. So here are some theorems that go with isosceles triangles. So if two sides of a triangle are congruent, which means it's isosceles, so basically if you have an isosceles triangle, then the angles opposite them are congruent. So the angles, I'm going to use a different color here. The angles opposite are congruent. So that means that angle B is congruent to angle C. So that is the sides opposite. So again, isosceles triangle, then the base angles are congruent. So if you have an isosceles triangle, then the base angles are congruent. The converse, again, if you remember what converse is, it switches the if and the then around. So now we're saying if you have these two base angles that are congruent, then you have the sides opposite them are also congruent. So that means now if your base angles are congruent, then the opposite sides, or the legs, which is the legs, are congruent. And these are very useful theorems. So we can use them to find missing values in a triangle. So it says find the values of x and y. Well, you can see that these are marked congruent. So this is an isosceles triangle. So that means the angles across from them are congruent. Well, we know that the three angles have to add up to 180. So if we take 180 minus and subtract 32, we get 48. So it's 48 degrees left in the triangle. Both angles are congruent, so we divide by 2. So that means angle X is 24 degrees, and angle Y is also 24 degrees. In this next example, again, we have this is marked congruent. So we know the angles opposite them are also congruent. So that makes Y equal to 70 degrees. And now if we find X up here, we have to take 180 and subtract 140, the 70 and 70, and that gives us 40 degrees for X. So let's continue on, but do the same kinds of things with algebra. So now, again, your triangle is a little bit different, but here are your congruent sides of your isosceles triangle. So that makes these angles congruent. So that means that 9x plus 12 is equal to 12x minus 6. So now when I move all the x's to one side and all the numbers to the other side, I'm going to get 3x equals 18 and x equals 6. Now I need to find y. Well, I'm going to have to substitute in the value of x in order to find it. So if I take 9 times 6 plus 12, that gives me 66 degrees. So this angle is 66 degrees and this angle is 66 degrees. So now to find y, I'm going to take 180 and subtract 66 twice, or just subtract 132. So then y is equal to 48. In this next example, what I have here is I have this side and this side are my legs. So we have these two angles are congruent. So what we have is we have an x in one and a y in the other. So what we need to do here is we would actually have to set up a system of equations to solve this. And that might be a little bit beyond where we want to go in this video lesson, but you can go back and see if you could even set this up and know what to do, and then you can check out the notes and see if you were able to set this up correctly and solve using a system of equations. That is the same side, so let's move forward here. This is the corollary to the base angles theorem. And remember, corollaries are just kind of natural things that occur from the actual theorems. So if we know a triangle is equilateral, then it's also going to be equiangular, because look at, if you just look at these two sides being congruent, using the base angles theorem, the sides directly, or the angles directly across would have to be congruent. But if we look at different two sides, if we look at this side is congruent to this side, then the angles directly across from them, those two sides would also be congruent, and that makes all three sides congruent. And then the converse is also true. If all the angles are the same, then the sides across from them will also be the same. So let's see if we can solve a problem using the corollaries to the base angles theorem. So solve for x and y. Well, we can see all three angles are congruent. So that means that the sides across will be congruent. So all three of these sides will be congruent. And so what we have then is that y plus 4 would equal 11, and we would have 2x minus 3 would equal 11. And when we solve, we simply get y equals 7. And obviously x would also equal 7 in order for those both to be 11. Maybe this is a little bit more interesting one. Maybe makes you think, challenge your thinking a little bit more. So let's try this one. So find the values of x and y. Well, we know these two sides are the same. So we know the angles across will be the same. So that means this angle right here would also be x minus 2. So now we also know that if we add all four of these angles together, the two that are congruent and the one that is not, they have to equal 180. So that means that x minus 2 plus x minus 2 plus that third vertex angle, 4x plus 10, has to equal 180 degrees. Now when I combine like terms, I'm going to get 6x plus 6 equals 180. Solve for x, and we're going to get x equals 29. Because we subtract 6, we would have gotten 6x equals 174. So we found the value of x. So now I can plug x in right here, and this would be 29 minus 2, so it makes this angle right here 27 degrees. So now I know that 3y is equal to, it's a linear pair, so 3y plus 29 has to equal 180 degrees. So now I subtract from 180. That gives me 3y equals 151. and then divide by 3, and y equals equals 50 1/3. All right. So let's move on to this last example here. This will be the end after this example of this lesson. So let's see if we can figure out what's going on here. All right, so we have this side and this side are marked congruent. So that means this and this are the same. So this is going to be 2x minus 5. We also have this side, and this side marked congruent. So that means that these two are the same. So we know 9y plus 28 has to equal x plus 5. And we also know, oh, this should be 25. 2x minus 25. Like that. So we have x's and y's in the same equation. So what we need to do here is a little bit more complicated. So I'd like you to challenge your thinking here and see if you can come up with the solution for x and y. And then check back to the notes to see if you got it right. And this is the end of lesson 4.2.